A vehicle emits sound of a constant frequency, and a stationary observer hears the sound. The vehicle moves directly towards the observer at constant speed. So this is the important point here, that vehicle is moving towards the observer. With a constant speed, the observer hears sound of frequency f naught. Now, the thing is, it's a natural phenomena in our 3D physical world, that if something is moving and it is generating a sound of frequency f, and if it is moving, then the stationary observer will receive the sound of a different frequency. So it might be less than, so f naught will be observer, and the observer's frequency, observed frequency could be less than, or it could be greater than the original frequency. It's just like whenever you hear the sound of an ambulance, and if it's going away from you, you will receive the lower frequency than the actual frequency. And if it's coming towards you, then you're surely going to receive higher frequency. So the point is, when it is moving towards the observer, the frequency will be greater than the original. And if it's going away from the observer, then surely the frequency observed or frequency received by the observer will be less than the original frequency. So they're saying the vehicle then accelerates, still moving towards the observer, travels at the higher steady speed for a time, and then decelerates until it stops. And we need to figure out what is the variation in the frequency of the sound that is heard by the observer. Now, we need to observe it closely, okay, to actually feel like you are the observer and you are going to receive the emitted sound waves from the vehicle. So initially, the vehicle was moving towards the observer with a constant speed, and we can say that initially the observer will receive a constant frequency, and for some time the vehicle accelerates, and this means the frequency will increase for some time, and then it comes to a stop, and this means the frequency that observed by the observer will again remain as a constant when the vehicle comes to a stop, because moving with a constant speed and coming to a stop is like same for the observer, with no change in frequency. Or it could be higher in the case of when the object is moving, but the amplitude can change actually. So which option can we go with? The observer frequency will fall, then remain steady, then return to the frequency f naught. Okay, it will not fall. Okay, why? Because the vehicle starts accelerating, so it must increase, right? Because it's accelerating towards the observer, so this should increase the frequency observed by the observer. So I can say that these two cannot be an option. Why? Because they both are saying that observed frequency will fall, and this might not be an option. This is not an option actually. Now the observed frequency will rise. Yes, we can say that. So both C and D, but actually which one is telling us the right thing is the observed frequency will rise, then remain steady, then fall to a lower frequency than f naught. Yeah, because see, the vehicle, the difference between option C and option D is the final frequency is f naught, and the final frequency in part C is lower than f naught. And see, the point is the vehicle decelerates until it stops, because here it is mentioned that, see this, the vehicle decelerates until it stops. So this clearly indicates that the observed frequency will be much less than or it will be lower than the frequency f naught, because f naught is the frequency when the object was moving with the constant speed. Yeah, so option D cannot be the right option. Why? Because they are saying that the final frequency will again to f naught, and that is not the case, because the object is not moving with the constant speed. It decelerates to a stop. So we can say that option C is the right option.